All right, so what we're going to go over today is a little bit of stuff about graphing, but mostly we're going to be looking at how we use Google Sheets to make a proper line graph, right? Because we're going to have to build line graphs quite a bit in this unit, okay, and be able to calculate things about those lines. How many people are taking Math 10 right now? Oh, so not many of you. Okay. Strange. Usually math and science go the same semester. But all right, that's fine. Okay, so what we're going to be looking at here is the graphing equation. We actually looked at it the other day when I was teaching you the rules of algebra. Okay, that's this one. We'll be looking at how that works with a graph, okay, shortly. But first, what's the purpose of a graph? Why do we make graphs?
Like to present data?
Yeah, to present data. And present it in like a visual way that can be quickly interpreted, right? If I have a graph of this information here, which is the effect of temperature on photosynthesis, I can very quickly see that in general, an increase in temperature causes an increase in the rate of photosynthesis, but at a certain point, it collapses, okay? It gets too hot and photosynthesis shuts down. I can read that directly off that graph very quickly. It would take me a lot longer to interpret that data if it was just in a chart with all numbers. Okay? Because I'd be like, okay, so now it's this number, and this number goes with this number goes with this number, and it's much longer and more difficult for me to interpret. Okay? This is a quick visual representation of the data from probably many experiments, okay? But I can read it very quickly and learn something from it. So that's the purpose of a graph, is to present data in a easily interpreted way. All right, so to build a graph, what are some requirements of a graph? What are some things a graph should have?
An x-axis and a y-axis.
A graph should have an x-axis and a y-axis. Okay, what else?
Labels.
Labels, yes. Both the x-axis and the y-axis should be labeled. Okay, they should have what's on them. So if we go back to this example graph, temperature in degrees Celsius on the x-axis, rate of photosynthesis, there's no units for that, I don't know what it is, okay, on the y-axis. All right, what else needs to be on the graph? A title. Question? Yeah. Yes, because I was doing this test yesterday, and yes, okay, so we got to have a title. Okay, graph needs a title. If I don't put a title on a graph, even if the axes are labeled, it's a lot more difficult for me to figure out what's going on here. Okay, what else does a graph need? Yeah, or at least points. Not all graphs are going to have a line because they don't. Maybe they have a curve, okay, or something like that. But yeah, they definitely have to have the data points on them. Okay. Now, when I'm looking at a graph, this is obviously a graph of an experiment that was performed. Which of the axes has the manipulated variable on it? The x-axis. Yeah, the manipulated variable always goes on the x-axis. So we can see the effect on the responding variable as the manipulated variable changes. Okay, so as temperature increased, temperature was the manipulated variable, the rate of photosynthesis rose and then fell drastically. Okay, so rate of photosynthesis responded to the temperature. Manipulated variable always goes on the x-axis when you're making a graph. Okay, everyone all right with that? So what we're going to do now is I'm going to walk you through how to build a graph in Google Sheets, and then we're going to calculate a few things about it. Okay, so the first one that we've got on your sheet is the circles one, the radius and circumference? Yeah. Okay. All right, so let's have a look at that. I'm going to sit down and walk you through it. Okay, so just follow along with what I'm doing here in order to build this graph in Google Sheets. So I make sure the pointer is in the cell 1A. Okay? Click and drag until you've highlighted all the cells that have data in. Okay? Now you're going to go to Insert. Click on Insert, and you want to insert a chart. Am I going too fast? Is this something you've all done before? Most of you? Okay. All right. So it'll be quick. All right. So sometimes Google Sheets picks the right kind of graph. Sometimes it doesn't. Today we were lucky. Okay? It actually picked what we call a scatter chart. If it doesn't pick that, then you have to click in here and scroll through all the types of graphs that Google likes to pick when it's building graphs. Okay? Often it picks like a bar graph, okay, which we don't want. But today it picked the right one, okay, which is a scatter plot. It shows all of our individual points. Everybody with me? All right. So now that I've got that, okay, now I want to double check that my graph actually has everything it needs. Well, circumference is here. It's labeled in meters, so that's good. Okay, diameter's down here in meters, so that's good. Okay, that was my manipulated variable. Okay, as diameter increases, so does the circumference of the circle. Okay, and then I've got this title here, which, you know, it's okay. I mean, it's circumference versus diameter. That is what's on the graph, but I probably would want something a bit more descriptive. So if I want to change any of the layout of my graph, I go over here to Customize. Okay, and in here you can pick all the kinds of things that you can customize. So I'm going to pick Chart, Axis, and Titles right now. Okay, and right now I'm on Chart Title, but if I click there, I can change the X-axis or the Y-axis titles. Okay, so right now I'm just going to change the chart title, and I'm going to say Circles Graph. And then maybe say diameter versus circumference. All right, you can see that as I type that, it actually changes it up here. That should be up there. All right. Underneath that, you can change things like what font you want to use, and you can make it whatever you want. You can make it look silly. Okay, so it's up to you, and then you can change the font size if you want all of that. All right, next thing I want to look at is my series. Okay, because right now, all I have on there are my points, and I actually want to have what's called a line of best fit, or what Google calls a trend line. Okay, how many people have heard the term line of best fit or best fit line? Okay, so a best fit line is a line that is drawn that shows the trend of your data. Okay, so it follows the trend of your points. Luckily for you guys, you never have to figure out where this line goes. Okay, back in the day when all of this was done with pencil and paper, okay, you had to take a ruler and draw the best fit line yourself and figure out approximately where it should go. Which meant that in a class of 30 people, you could get 30 different best fit lines, okay? Most of which would be okay, right? In this case, Google will draw it for you using its algorithm that tells it where to put the line, okay? So I'm going to go to Series, and I can change my fill color, I can change, okay, all of that kind of stuff if I want to. I can make them, instead of circles, I can make them stars, whatever, it's up to you. Okay, if you're graphing more than one thing on the graph, then you might want to do that. Okay, all right, so the next thing we want here, we've got error bars, data labels, and trend line. We want to check the box for trend line. And once I do that, it draws my line of best fit, which for this graph just happens to go right through every point. That happens very rarely. Okay? It only happens on this graph because for every one of those points, circumference is 3.14 blah, 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 blah times bigger than the diameter. Okay, so they all line up absolutely perfect. Okay? That, like I say, very rarely happens. All right, so I've got my trend line drawn. Okay, then I want to go a little bit further down to where it says label. The default is none. I want to click on that and put in use equation. This is the other nice thing. Google Sheets will spit out y equals m times x plus b for this graph for you. You won't have to figure it out. Okay, so as soon as I click use equation, I get up here this little equation here. So what they have done is they have said that y equals 3.1 times x plus 0.149. So this is m times x plus b. Okay, so it does all the calculating for me. Everybody with me so far? No?
You just press the one.
Yeah, you have to check the box that says trend line. So up here, trend line. Yeah? And then down here, label, use equation. Okay, so now, this next part you're going to need a piece of paper for. Okay? You're going to do a little bit of calculating with the graph that we just built. All right, so when we made this graph, okay, it looked like this, right? And so what Google has told us is that the equation for the line on this graph, which we normally write like this, y equals mx plus b, okay? For this graph, that is y equals 3.1, and if they showed us more decimals, it would be 3.1 for all the other things that are part of pi, okay? Times x plus b, all right? So that's 0.0000. Okay, so you see how this is written here? This is written like Avogadro's number, okay? 1.52 times 10 to the minus 5. That's 0.000152, okay? That's what that number is. Okay, so before we go any further, this equation tells me a few things, okay? Y is the y value of any point on the line, okay? Not necessarily on my graph, but on my line, okay? X tells me the x value of that same point. So this would be y, and this would be x, okay? So they can change depending on where on the graph I am. B is my y-intercept. It's where my trend line crosses the y-axis, okay? For this graph, it should really be 0, but there's experimental error here, okay? And we're getting this incredibly small number, because a circle with a diameter of 0 would also have a circumference of 0. I mean, if it's got no diameter, it's not a circle, it's a point, right? Okay, because circumference is pi times diameter. Diameter is 0. Circumference is 0. Are we following me there? Okay. So B is where your line crosses the y-axis. So in this case, it's down here. Right? M is the slope of the line. It tells me how much it goes up as a function of how much it goes over. Okay? So you may have seen this somewhere. Okay? Slope equals rise over run. And people have seen that before. Okay, so that's like the simple way to calculate slope. All it will do is calculate slope. Okay? We want to use this equation to get slope, which, oddly enough, will come back to this. If I manipulate this equation for m, okay, and I follow the rules of algebra, what do I move first? B. Okay, so I'm going to have y minus b equals m times x, and I want to get m by itself, so what do I do with x? Divide. Okay, so m is the slope, okay, and the slope is rise over run. Well, if I go y minus b, did I just calculate the rise? Okay, and if I go whatever x is, did I just calculate the run? Okay, so this is basically the same thing. Slope is rise over run, but we almost never write it that way in physics because we're usually using the graphing equation instead. Okay? All right, so the purpose of the graphing equation is that it can help us to extrapolate for things that happen beyond the graph or for points that aren't plotted on the graph. Right? So the first question here is calculate the circumference of a circle with a diameter of 0.88 meters. All right, so they want me to calculate a circumference. Which axis is circumference on? Y. Okay, so they're asking me to calculate y. Right? The Google Sheets gave me what m is, it's 3.14, okay? And it gave me what b is, this number here, and that question told me the diameter is 0.88. What axis is diameter on? X. So there is my x value. It's saying calculate y when x is 0.88 meters. Everybody with me on that? Okay, so all I have to do is plug in my numbers. Okay, so according to that graph, okay, I would just go 3.14. Okay, times 0.88, that was the x value they gave me, plus that 1.52 times 10 to the minus 5, okay, which is essentially 0. Okay, so are we really just going pi times diameter? Okay, so we're basically just graphing how circles grow, okay, as diameter increases. All right, so if I do that, okay, sorry, I forgot to fire up my calculator. I should get a circumference of so I get a circumference of 2.76 meters.
So will we put y equals 2.76?
Yep.
Okay.
Meters. Put the M on. Units are important. All right. The second question is asking you now, calculate the diameter of a circle, which will be y or x? X. When the circumference, which is y, is 41.5 meters. Okay, so 41.5 meters is obviously way beyond this graph, right? This doesn't even occur on this graph. This graph only goes to 5, all right? So, can I calculate that using this equation? Okay, you try. You're trying to calculate the diameter using this equation. Okay, so you're looking for an x value. You know what m and b are, and it told you y. Okay, see if you can solve for x. I'll give you a minute. Okay, so let's have a look at that one. So if I want to manipulate this equation to solve for x, which is what I have to do because diameter is on the x-axis, okay, I would first subtract b, just like I did before. So we'll have y minus b equals m times x. If I want x by itself, what do I do with m? Divide, yeah, multiplying them. So if I want to move m to the other side, I do the opposite. Do it to both sides. Y minus b over m should give me x. Okay, so I'm going to have 41.5 minus that tiny little number, which is effectively 0. Okay, so 1.52 times 10 to the minus 5, okay, divided by 3.14. So basically I'm taking the circumference and dividing by pi and getting my diameter. Okay, so I'm going to have 41.5 minus 1.52 negative 5, and then divide that by pi. Now, on your calculator, if you were doing this and actually needed to use pi, you should use the pi button. But here I'm using the slope Google Sheet spit out for me, which is just 3.14. Okay, so 13.2 meters is the diameter of that particular circle. Everybody okay with that one? All right, what's the next one here? Okay. See if you can build this graph. Exactly the same way you built the last one. All right, give you a couple minutes to see if you can get that graph built, okay, with all the stuff that it needs to have on it. How do you like it? Oh, the new data, just click down here on the bottom. It says circles graph and then it says rubber band.
Oh, okay.
Just click on the tab that says rubber band. Okay, and it'll give you this data about how much force is used to stretch a rubber band. Okay, so the stretching force is the manipulated variable, and the length of the rubber band is the responding variable. So, if we're building that graph, we quickly highlight everything. We go to insert, we go to chart. Okay, it picks the right one for us. We go to customize. We go to series. We get our trend line, and we get our equation. Boom, there we go. Okay, it says that our slope is 2. Okay, and our y-intercept is 6.5. And once again, this very simple graph has all the points directly on the line. Again, that does not usually happen. Okay, usually you get a smattering of points above and below the line. Okay, when you do this. Just grab a copy. And your phone. All right, so now we're going to look at some calculations to do with that one. Okay, so here's our rubber band information. Okay, there's our graph for the rubber band. Okay, we got our y equals 2 times x plus 6.5. Okay, so I want you guys to see now if you can do those calculations right there. Okay. Solving for how long the rubber band would be if it was stretched with 15 newtons worth of force. Okay, what force would be needed to stretch the band to a length of 18.7 centimeters, and how long is the rubber band when it's not being stretched? Okay, give you guys a couple minutes, see if you can solve those questions. All right, so for this graph, okay, the equation for the line is y equals 2x plus 6.5. Okay, so we're trying to calculate how long the rubber band will be. Length is on the y-axis, force is on the x-axis, so what they've given me is force, that's an x value. Right, so I know what x is, I know what m is, okay, and I know what b is, so all I have to do is plug in the numbers, and I'm solving for the length of the rubber band, which is on the y-axis. So for question number 1, this is just going to be 2 times 15 plus 6.5, which is going to give me 36.5 centimeters. Okay, everybody all right with that one? Okay, how many people have done the second? Okay. So on the second one, they're asking me calculate the force. Okay, which axis is force on? X. So now they're asking me to solve for x, and they're giving me length, which is y. Okay, so I have to manipulate y equals m times x plus b. So I'm solving for x this time. So I subtract b from both sides and then divide by m. Okay, that'll give me x. So my y value, 18.7 centimeters, minus b, which is 6.5, divided by the slope, which is 2. Okay. Incidentally, that slope is 2 meters per newton. Okay, so basically, if you use 1 newton of force, the thing will get 2 meters longer, 2 centimeters longer. Okay. All right. So now that I have that, now I can just plug in my numbers, and I'll have my force. Okay, so we've got 18.7 minus 6.5, and then we divide that by 2, so we're going to get 6.1 newtons. Questions there? Okay, it's just a pretty easy formula to use. Okay. As long as you understand which is x and which is y, you really can't go wrong with it. All right, now number 3 is asking about another part of this. Okay, how long is the rubber band when it's not stretched?
B.
B. Okay, B is our y-intercept. The y-intercept is whatever y is when x is 0. Okay, so when the rubber band is not stretched, it's 6.5 centimeters long. Okay, because there's no force on it. Okay, so its length, unstrained length, is 6.5 centimeters. Everything after that is how long it is once I start stretching it after that. Does that make sense to everyone? Okay, so that's the importance of the y-intercept. The y-intercept is kind of your starting point. What is y when nothing is happening yet, okay, in terms of x? Okay, questions on that one? Okay. Let's try the multiple one here, okay? I'm gonna walk you through this one. Okay, this is how we plot multiple things on the same graph. Right? So if I had 3 carts and I was racing them, okay, this would be their position versus time data. So measuring where they are as a function of time. Okay? If I want to put them all on the same graph, I make sure that whatever I want on my x-axis is the first column. Okay, that's the way Google defaults. Okay, the first column will be x, everything else will go on the y. Okay, so same as I did before, I click and drag until I have all my data highlighted. And then I do all the same steps. I go to insert, go to chart. Okay, but here's where Google starts to get confused. It thinks I want a bar graph. It thinks wrong. Okay, I don't want that. So I have to go to chart type right here, where it says column chart. Click on that and scroll down until I get to the one I want, scatter, which is like halfway, more than halfway down. Okay, so scroll down to scatter. All right, now I get 3 different sets of data. Right, and it's showing me there's 3 series. There's the position of cart 1, the position of cart 2, and the position of cart 3. Right, that's good. That's what I want. All right, so now I'm going to go over to customize, and you'll notice that it doesn't know what to put on the y-axis because there was more than 1 column, so there's no label. Do I need a label? Definitely. All right, so I'm going to go to customize. I'm going to go to chart axis and titles. Okay. Probably don't want to use this. This doesn't make much sense as a chart title. Right? So I'm going to say position versus time or something like that. But not the chart 3, because that doesn't make sense either. Okay, position versus time. And I'm going to make sure that I get a y-axis title. What's on my y-axis? Position of the cars in meters. All right, so that stuff's all set. Now, when I have this data, do I want one best fit line or do I want one best fit line for each car?
1 for each car.
One for each car. They're separate sets of data. Okay, so I'm just going to go down here to Trendline. Okay, click it. And Google will default to actually drawing a line for each car. All right. Now, if you look closely at these dots, you'll notice that not all of them are exactly on the line. Okay. And what I often do is I actually make the points a bit smaller, and then it's a little easier to see that they don't sit exactly on the line, which is the way most graphs work. Okay. All right. So now that I've got those, I've got my trend lines. Now I want to come down here and get the equation for each line. Alright, so now it's showing me y equals mx plus b. Catherine, do you have a question?
Yeah, but I'll come after.
Okay. It shows me the equation for each line, right? Now, on this particular graph, it's showing me how far each car goes as a function of time. So, the steepest line is the fastest or slowest car? Fastest. It covers the most distance in the same amount of time. That means this number here, m, the slope, is actually the speed. Okay? It's telling me how many meters it goes every second.
Mine only shows one equation. How did you get it?
You have to apply it to all. Did anyone else only get one equation when they did that? Okay. If that did happen to you, you just have to go up here where it says series, and if it doesn't say apply to all, it might just say one or two or three of them. Just click apply to all, so it does them all. Okay. All right. So that gives us our equations for those cars. That means the yellow car is moving at 3.39 meters per second, okay, and had a starting position of 0.0381, okay. Car 2 is moving at 2.01 meters per second and had a starting position of negative 0.0524, means behind the start line a little bit, okay. And for cart 1, it's the slowest, only moving at 1.38 meters per second, and its starting position was just barely behind the starting line. Everybody okay with that? All right. So then, we just talked about the velocity of each cart. Agreed? We said it was the slope because that tells us how fast y is changing as a function of x. That's meters per second. Okay. What I would like you guys to try is 2 and 3. Calculate the position of each cart after 12 seconds. And how long it'll take each cart to reach a position of 50 meters. And we'll probably end up going over that tomorrow. Okay, but this is going to be important when we actually walk through this because we're going to do a lab just like this.